Find the function whose graph is shown below. Looking at this, we see our midline is here at 2. And it's pretty easy to see the x-coordinate at 0, also on the midline. I'm going to do the one on the midline just so that we can see a phase shift, and it really doesn't matter, which one you do. So this one, I'm going to pick this right here as my starting point. I see the x-coordinate there is at pi. Now, when we have a point on the midline, we can model it using a sine function. So we're going to be looking at a times sine of bx minus c plus d. Now again, I could have used the starting point up here at the maximum, in which case I would have written a cosine function. But I'm just for the sake of seeing something that is not at 0, but has a phase shift, I'm going to do the sine on this one. The amplitude is our distance from the midline to a maximum or minimum, and we see that that is 1. So I'm going to write out a equals 1. I'm going to talk about positive and negatives here in a minute. To get b, we use our period. Now the period here is, the distance it takes for a full cycle. So I can't see where it finishes the cycle over here, but I can see the distance from peak to peak. And that distance is a distance of 4 pi. So 4 pi, that's 2 pi over b. Okay. And then I can solve for b. So multiply by b and divide by 4 pi, and you get b equals 1/2. So with a and b, you then need to look at your signs, positives and negatives. And here, viewing this as a sine function, my starting point right here on the midline, it starts by going down. And when it starts by going down, that means a and b need to have different signs. One needs to be positive, one needs to be negative. And it doesn't matter, you just pick one, and then from there, that will determine your phase shift. I am going to choose a to be negative. I prefer leaving b as a positive number, but it doesn't really matter. So I'm going to let the a be negative here. Now I'm going to go through and get my c for my phase shift. Now the phase shift is c over b, and that is equal to the x-coordinate of this starting point, which is pi. So c is pi times b, which is 1/2. So I get c equals pi over 2. And finally, d, of course, is the y value of the midline, which is 2. So now I can plug these in. I get a equals negative 1 times sine of 1/2 x minus pi over 2, and then plus the d, which was 2. Again, this is was using the sine function. But you could have just as easily have done a cosine. I'm going to go ahead and just write out what that would have been, just so that you can see it. If you had modeled this with a cosine, using that starting point, it would have been y equals cosine of 1/2 x plus 2. Okay, you can see the amplitude, of course, doesn't change. The period is the same, but there's no phase shift here because it hasn't moved from the axis, but it did still move up 2. So this would have also been correct, and you could check on a graphing calculator. You could graph both of these and see that they are the exact same graph.